Today I will be covering the challenge GB3000 from Hack the Box. These are the tools that I'm using to solve it. So I have SaneBoy, which is a Game Boy emulator and debugger. I also have Visual Boy Advance, which is another Game Boy emulator. It's just more stable than SaneBoy, so I'll use this to solve, ultimately to solve the challenge. The How to Reverse Engineer and Patch a Game Boy ROM by Stack Smashing YouTube video. This is a great tool for you who want to begin understanding the inner workings of a ROM, and the Gidra Boy extension from Gekio. So I'll be using this, and I already loaded the binary in Gidra. I already loaded the extension in Gidra. It's good to go. And one thing that is important to note right off the bat is this binary that I'm analyzing is a patched binary. What this means is that I changed so I do not reveal what is the actual solution and what is the actual flag for the challenge, but I can still give you an overview of the inner workings here and how we're going to analyze this function, right? How we're going to analyze this binary. And to give you a quick look on how this works, so I'm going to load Visual Boy Advance here, and I'm going to load my patched binary here, and that's okay. I don't need the sound driver. So basically what it does is that you can press the direction keys or the AB keys, and then it will do nothing unless you find the correct sequence. So if you hit enter, it resets everything in case you make a mistake. So we have to find the correct sequence that will print us the flag. That's the objective. And that's what we're gonna do using Gidra and using SaneBoy. So in SaneBoy, I'll use the debugger. And let me expand this a little bit. Good. Let's load the binary here and leave it running here. Okay, so as you saw in my demonstration, it kind of keeps reading keys from your joystick, and from that we can assume that there is a loop going on, an infinite loop that is constantly reading our keys until we have the correct sequence of keys, and then it will eventually break out of that loop. And right here on the entry function, we can see a big while true right here, which is an infinite loop that is doing a bunch of stuff, is doing a bunch of comparisons right here. And then you can see that there is a break statement. So we can start from the assumption that this is the logic reading our input, and then we want to try to break it. So when we break it, we can come to these functions, and then they will map to which pixels will be, will be active, let's say, that will print us the flag. So heads up, because this is patched, it will not show the flag, but you will see the animation of when we have the right sequence. Now, let's see here. So our goal is to hit this break, okay? So in case our assumption is correct. So to do that, we kind of have to find the condition here where we meet all of these conditions. So because this is an infinite loop, you can assume that these functions, they will be called all the time. So we want to see when we can pass this first check, right? Because this first check, every time it goes wrong, it will not continue, then you just go to the rest. So you want to see what happens when we reach here. So for that, I'm going to click here on this function 3BB. I'm going to find it here in the listing window. And then I want to see what this comparison is having. So we see that right here is a comparison, and it's comparing to 0. So if it is not 0, it will jump, right? So I want to see when it hits this address right here, the 189. So I'll set a break at 189, and then I'll continue execution. It's already executing actually. So I'm just gonna play around here with the game and see if it breaks. Okay, so it broke. All right. What we want to analyze now is what are the values here, right? Because if it broke, we reached this line right here. So we can see that the address C001 is being passed to HL, and we can confirm right here, C001 passed to HL. And then, it's going to call these functions here, gonna assign this value gonna assign the result to this variable right here, and then it's going to compare that variable to 1. So if it passes this function right here, it goes to the next one, it goes to the next one. We could go ahead and try to call this like validate input, right? So maybe that's what it's doing, is validating input. Okay, so right here we are going to continue execution until we hit that call 27A. So we're gonna see the arguments being passed, which are, I think it's A and B. You know what? Instead of doing this, actually what we're gonna do is I'm just gonna continue execution here. Does it always break? Yeah, it always breaks. So let's reset. Let's continue. And then this time what I'm gonna do is I'm just gonna say that everything is up. Okay, so now it broke, right? So I wanna see if this is input, and then it's taking this address right here. It's possible that this address contains our inputs, right? So we're gonna go and check, examine the C001 address. Okay, good. So we see a bunch of 40s right here, right? We see 16 40s and we entered 16 ones. So we know that, I mean, it's still an assumption, but we're pretty sure that number up arrow corresponds to 40. We can try to do another one right here. Instead of going up, let's go this time just down and see if there's a different number. Okay, so now we examine there. Okay, it's about, everything is 80. So we're mapping this, huh? So we know that up is 40, down is 80, so and so. What I think I'm gonna do here is that I'll open a C compiler, and I like to open this online C compiler just so I don't have to do it myself when I'm doing this simple scripts right here. So I know I can have a I think there's a byte, let's call this joystick, and then I think this is how I do it. I'll have to check here. Let's move this out of the way just a second. And what did I do there before? Okay, first of all, we need to include std int.h, and then we need to include std lib.h, and then a type of uint 8 t byte. Okay, and then so now that the byte is defined, I can first of all map the joystick. So we know the joysticks, we have the keys A, B, right, left, up, and down. We also have enter, but we don't care really about enter right now. And then let's name this byte. So there's A, B, right, left, up, and down. So we know that up is 0x40. We know that down is 0x80, right? And then we can continue doing this for every other one. So I can just reset this, continue. I can go and try to just hit, let's say letter A this time, check the break, examine the stack, and now it's 1. So eventually you get to the result that A is 1, B is 2, right is 8, and left is, right is actually 10, and left, and I mean hex 10, right? And left is hex 20. Okay, So we have these things mapped here to the joystick. Right. So now looking in Ghidra, we are validating this input, right? And then the parameters we're passing right here, it's our byte sequence, and then something else in this XA1. And another thing important to notice right here is that here we have that position at 001, then you have 05, 9, D. So it's always increments of 4. So since it's increments of 4, we can assume that this is evaluating the lines. So let's call this validate input line. So here we start from the beginning, right? So here, let's call this input line. And then we don't know exactly what this one is yet. But first of all, we take here, this variable here is taking the second element of the input line. So let's just call this input line 2. Oh, it resets. Okay, this is an extension problem. So we're not going to rename these variables. We just name that one. Can I name this back? Input line? Yeah, okay. Good. So first of all, we're checking here if the second element of our input line, which is this one, is equal to the first element of our input line. So that means the first two characters must be the same. And then we're checking if that second element is equals to hex 80. And if you go in our mapping right here, we see that down is hex 80. So that means the first two characters must always be down. Okay, so we're gonna have this, let's call this valid sequence or valid seq, right? So where we have down and down as valid sequence, because it tells us right here, right? It always has to start, the second must be equal to the first, and the second must be 80, which is down. So if that condition is met, we are taking that element and saving this variable right here, which is, let's say, a temporary variable, and then we're saying that the new variable is basically the next line, right? Because it's taking that input line plus 4. And then it will do a second check. It's going to check if the input line at position 3 or input line position 2 or that temp variable which contains the second element is equals to this parameter 2. And this parameter 2 is the value that was hard-coded there in the application. So if you go back here in functions, you see that it is a hex A1. So we're checking if those are equals to hex A1, right? And then if they are, it will return. Now this code right here is not super correct, because it says it returns like in both ways, but if you see right here in the listings, like in the assembly, it returns like it's 1 to A if it's correct, and it's 0 to A if it's incorrect, right? So there should be let's say a PB var2 equals 0 right here, PB var2 equals 1 if this is correct. But anyways, we need to find a condition where the third or the last element of that line, or the second element of that line, and or, I mean, this is stuff. So the position 3 is the number 4, position 2 is number 3, and then this one we assign number 2. So this 3 here being OR must be equals to hex A1. So we can do this right here. Let's just do this for now, and then DD. Okay. So we could start with assumptions, right? So we could say just AA. So AA. Let's see that this is the valid sequence, right? Okay. So what we want to do is sort of a mimic this function right here in Gitra and try to find what are the conditions where, you know, the inputs 3, 2, and 1 will be equal to that. So we know that the check value, so the check value, which is a byte, is hex A1, right? So we can go and do for int I equals 0, I less than 4, I plus plus. So we go here and iterate the 4 lines of the screen. So then we can do a comparison. So what we want to do is that we want to compare the valid sequence on position 3. Yeah, position 3. Or, you know what? Let's try to sort of copy this function the way it is right here. No, wait. So we want so it's a valid sequence. So let's do this comparison equals valid sequence position. Instead of 3 is actually I plus 3, right? I plus 3? No. My god, I'm so crazy. So it's line 1, I times 3? No, still not. Okay, let's do this position 3. So int position 2, or actually position 1, and position 2. Don't mind my coding skills. And position 3. So valid sequence position 3. This will be, first of all, this is 1, this is 2, and then this is 3. Position 3. All right. Valid sequence position 2, and then valid sequence at position 1. Oh, wait a minute. Sorry, guys. I don't need this. I don't need to do for all line, because if you go back to entry, right here, it's all the same. It's all it's for 1. Hex A1. Sorry, hex A1. Okay, I don't really need to go through all the lines. So once I find the first correct sequence, I find everything. So here, instead of doing this, I'll just do really 3, 2, 1. Yeah. And then I need to check if it's going to be comp equals to my check val. So if my check is equals to 1, or actually if my check is different than 1, then I can say, all right, this is not valid. Let's just see how our code is going so far. So let's do, let's print this. If it's not 1, not valid sequence. And then we can print the result of the comp. So we see how it's going there. What am I missing here? Okay, semicolon here, semicolon here. Okay, so it is going at 81 right here. And once again, I don't need this loop really. Okay, so it is at 81. So if we know that the 2 are down, we just need to know what are the 2 and 3, right? So what we would do is we would loop through the joystick right here and try to find a combination. So I guess since we're doing 2 of them, right, we're gonna go for int, yeah, let's call this int j equals 0, j is less than the size of the joystick, and then j plus plus. Why am I doing j first? This should be I, and then I. Okay, and then so for int j equals 0, j less than the size of joystick, then j plus plus, good. All right, so we would do this actually. So we're gonna see here, instead of the sequence 3, it's gonna be I, and then instead of the sequence 2, it's gonna be J, and then we're gonna convert this to byte, I think. Do I need it? Or actually, it's joystick at position I, and then joystick, of course, joystick at position J. Yeah, that's it. And then we're gonna redo this. And then now, if the check comes to 1, now we found it. So let's do this. So found pair. So the sequence 3 equals to the joystick at position I, and sequence 2 equals to joystick at position J, right? Yeah. So joystick position I, joystick position J. Okay. Does it run? Okay, it looks like it runs. Let's just clean it up a little bit here. Okay, so we found the pair. So it has to be either 1 or 20 or 20 and 1. So 20 is left, 1 is A. So that means we could do this, huh? If we run this again, yeah, nothing shows up, so code execution was successful. So now if I go back here, and this time I'm going to use the Visual Boy Advance, just because sometimes here in the same boy, what happens is that I press a key and then it goes twice. And then if we try that sequence, which is down, down, left, A, down, down, left, A, down, down, left, A, down, down, left, A. And there you go. As I said, the flag will not be printed just because I patched it, but you have the logic of the solution right here. And it all lies in disassembling this function right here, which was escaping this infinite loop. All right, hope you guys enjoyed.